Hello everyone, in today's video we are going to cover section 7.4 regular polygons. After studying this section you'll be able to recognize regular polygons and use a formula to find the measure of an exterior angle of an equiangular polygon. So we're going to take a look at regular polygons. The figures below are examples of regular polygons. Notice in my figure that each polygon has all sides and angles congruent. So the definition of a regular polygon is a polygon that is both equilateral and equiangular. So whenever I see regular in front of the name of my polygon, I should think all angles congruent and all sides congruent. Next, let's look at a special formula for equiangular polygons. Notice in my diagram I have an equiangular pentagon. I know a pentagon measures 540 degrees when I add all my angle measures. That would mean, if it's equiangular, each angle measure is 108 degrees. Now an interior angle and an exterior angle are supplementary, so that means angle 1 would be 72 degrees. And if I have an equiangular pentagon, that means each exterior angle would be 72 degrees, which leads me to Theorem 58. The measure E of each exterior angle of an equiangular polygon of n sides is given by the formula E, so the exterior angle measure, is equal to 360 divided by n. Because I know the sum of the exterior angles of any polygon is 360 degrees, and then I divide it by the number of sides of my equiangular polygon. So E equals 360 divided by n will give me the measure of the exterior angles of my equiangular polygon. Now looking at my sample problems, I have problem 1. How many degrees are there in each exterior angle of an equiangular heptagon? So using my formula for the exterior angles of any equiangular polygon, E equals 360 divided by n. I know a heptagon is 7 sides, so 360 divided by 7 would give me the measure of each exterior angle. 360 divided by 7 is approximately 51.4 degrees, or if I kept this as a mixed number, I could say it's 51 and 3/7 degrees. Looking at problem 2, if each exterior angle of a polygon is 18 degrees, how many sides does the polygon have? Again, using my exterior angle of an equiangular polygon theorem, 360 divided by n would give me the exterior angle. In this case, I have the exterior angle, so E will be replaced with 18. That's going to be 360 divided by n. I'll multiply by n, so 18n will equal 360. I'll divide everything by 18. So n, or the number of sides, would be 20. So I have a 20gon. Looking at problem 3, if each angle of a polygon is 108 degrees, how many sides does the polygon have? This time I'm given the measure of the interior angles. I'll use that to find the measure of an exterior angle. So 180 minus 108 would mean each exterior angle is 72 degrees. Now I can use my formula E equals 360 over n, where E in this case is 72, so 72 equals 360 over n. I will multiply by n, so 72n equals 360. I'll divide everything by 72, so n is 5. So I have a pentagon. Looking at problem 4, we have find the measure of each angle of a regular octagon. Now there's actually two ways that I could go about doing this. I could find the sum of all the interior angles of my octagon and then divide that by 8 to give me the measure of each interior angle. Or I can use my exterior angle theorem, E equals 360 over n, and then subtract that number from 180. So let's look at both ways. So if I use my sum of all my angles, that theorem was the sum of all the angles is equal to 180 times n minus 2. So this is 180 times 6, because an octagon is 8 sides. 180 times 6 is 1080. 1080 I would then divide by 8 to find the sum of each angle measure, which would be 135 degrees. Now my second case, I can use my exterior angle theorem, so E equals 360 divided by n. So E would equal 360 divided by 8. 360 divided by 8 would give me 45. So each exterior angle is 45 degrees. I know my angles are supplementary, so 180 minus 45 would give me 135 degrees. So each interior angle is 135 degrees. You could use either method for this. I think this way here, using the exterior angle, is shorter and saves more time. Looking at problem 5, find the measure of each exterior angle of an equilateral quadrilateral. Now, it doesn't tell me that it's equiangular, it just tells me that it's equilateral. And just because something is equilateral doesn't mean it's equiangular. So in this case, I actually don't have enough information to find the measure of each exterior angle. So really, there's no solution. In today's lesson, we learned a regular polygon has all sides and all angles congruent. And to find the measure of an exterior angle of an equiangular polygon, we use the formula E equals 360 divided by n, where n is the number of sides of my polygon. That's a wrap on today's video. We'll see you in the next one.